Okay, so anyways, let's go ahead and get going. If you don't have this at the top of your paper, go ahead and get it up there. But this is Unit 3-1. It is the complex number system plus imaginary numbers. Like I said, this is on your own notebook paper. Most of this unit will be strictly on your own paper, so just make sure that you come prepared to take notes every day. But again, Unit 3-1 is the complex number system and imaginary numbers. So let's get into it. You don't have to write anything down onto this. Okay. So up until now, maybe you have or maybe you haven't been taught about the complex number system. I know that in Algebra 1 and I think also in middle school math, they talk about the real number system, but all numbers are complex numbers. From complex numbers, we have what are called real numbers. Real numbers break up into two categories of irrational and rational. Rational numbers break up into fractions and integers. Integers break up into negative and positive or whole numbers. And then lastly, positive and whole numbers break up into zero and natural. And up until this point, that is all you've known. But today, we are going to introduce a new category of complex numbers called imaginary numbers. Okay, so we're going to have real numbers and imaginary numbers. Off this slide, I'm going to highlight what I want you to write down. Okay. So all complex numbers, which again, all numbers are complex numbers, but all complex numbers can be written in the form A plus BI. Now, leave yourself one little line to add a little bit to this. But in A plus BI form, we have the real part, which is the A. So we're going to label that as the real part. And the BI is our imaginary part. And with complex numbers that have real parts and imaginary parts, we always write them in A plus BI form. Okay, and again, that means just putting your real part first and your imaginary part second. That's a habit that we are going to develop over the next week and a half, where we are going to have a lot of lessons where we see complex numbers. And that's also a big part of our first standard, is being able to recognize complex numbers and imaginary numbers, but also being able to write them in the right form. Now, if you're looking at that A plus BI and you're like, okay, what does that mean? We have I, we have an imaginary part. I is the imaginary unit that exists such that I squared equals -1. Today, once we get a couple slides in, we're going to start building some key facts that we need to know, and I squared equaling -1 is one of them. And we're going to come back to that. I'm going to scroll down just a little bit so I can read these bottom two bullet points. Once you have what's in yellow down, just put your pencil down for a minute. So when it comes to a complex number, again, in A plus BI form, if it is missing the imaginary part, so if it's missing that I part, we simply refer to it as a real number. So when we think about real numbers, we think about like 2 or -8 or -30, like numbers like that. They don't have the imaginary part. And even though they are complex numbers, we're going to classify them as real numbers. On the flip side, if you have a complex number that is missing the real part, meaning it only has the I part, we consider that to be a non-real number, and we classify it as a pure imaginary number. Those bottom two bullet points I do not have highlighted because you're going to see that here in just a minute with some practice that we're going to do. But just make sure again that we know if it's missing the imaginary part, we consider it to be a real number. And if it is missing the real part, then we consider it to be a non-real number, and it's classified as a pure imaginary number. But as always, once you have this down, put your pencil down for a moment. Okay. Just another second. Okay. So So from this, you do not have to write the whole table. Just know homework number 1 looks like this. But I want you to just put some little stars, and I want you to write each of these expressions. Okay, or you can put bullet points, whatever you want. But homework number 1 looks just like this, where you're going to be given some expressions, okay? And it's going to ask you to do a couple things. The first thing that it's going to ask you is to classify each number as real or non-real, okay? Second thing that it's going to ask for is the classification itself, and we will either list complex, real, or pure imaginary. The next thing we will do is write in A plus BI form. And then the very last thing that we will do is identify the real and the imaginary parts. Okay. So looking at that first expression, we have 7 plus 84i. You can see here we have an I in it, which means that this number here is automatically non-real. Now you'll notice in the table, non-real has a hyphen. You can write it like this or without the hyphen. On the EOC, they write it both ways. I just write it without the hyphen myself. But again, 7 plus 84i has I in it, so that makes it non-real. Since it has both a real part and an imaginary part, the classification is simply going to be complex. Because again, all numbers are complex numbers, but if it has both parts, that's how we're going to classify it, is just complex. It is already in A plus BI form because it has the real part first and then the imaginary part second. So it's already in 7 plus 84i. You can see how that mimics that A plus BI. And then the last thing we're going to do is label the real and the imaginary parts. Now, on your homework, when you go to do number 1 like this, you can just write R and I, but I'm going to write out real, and then I'm going to abbreviate imaginary. But the real part is the number without the I, so it would be 7. And then the imaginary part is the number with the I. So you can see 84 is the coefficient. Oh, maybe not. There we go. 84 is the coefficient of that I, so the imaginary part would be the 84. Okay, let's keep going. The next expression that we have is negative 9i minus 4. Again, the thing that you were looking for is the I, so this would be non-real. Again, it has both parts, so it would be complex. Now, negative 9i minus 4 is not in A plus BI form. Brittany, how could we rewrite that so that it is in A plus BI form? Perfect. So negative 4 minus 9i. Okay, it's just flipping them around. Again, we need to label the real and the imaginary part. So the real part would be the negative 4. The imaginary part would be the negative 9. Okay. Next expression that we have is simply a 23. There is no I here, so this is going to be real for the real versus non-real. And then if you have it as real, your classification will also be real. So on your homework, if you put real in the first column, you're going to put real in the second column. Now, we are missing the imaginary part of our complex number, okay? Because again, in A plus BI form, A is the real part, BI is the imaginary part. If you are missing the imaginary part of your number, you're going to start by putting the real number plus, and then you're going to put 0i. Because if you think about it, anything that has a coefficient of 0 is simply 0. Because anything times 0, so anything multiplied by 0, is 0. So that's just acting as a placeholder. The real part here would be the 23. The imaginary part would be the 0. Moving on to the last one. The last one that we have here is 3i. Okay. Since it has an I, again, that means it's non-real. But since it only has the I part, so only the imaginary part, and it's missing the real part, its classification is going to be pure imaginary. So since it only has the I part, the classification would be pure imaginary. Okay. Looking at the A plus BI form, you can see here in this one, we put a placeholder for the imaginary part. But for this one, we're going to have to put a placeholder for the real part. So it's going to be 0 plus 3i. Real part in this case would be 0. Imaginary part would be the 3. And once you have that down, put your pencil down for a moment. Once you have that down, put your pencil down. You guys another moment. Go and do this down. Just put your pencil down. Please and thank you. Okay. For this slide, I don't want you to write anything down. But let's talk about squaring numbers. So it says, what do each of the following equal? So we know that 2 squared is equivalent to 2 times 2, which is equal to 4. Okay? Because remember, an exponent is just a visual representation of how many there are. Okay? Same thing here. We have negative 2 squared, which is the same thing as negative 2 times negative 2, which again is 4 because a negative times a negative is a positive. 0 squared is 0 times 0, which is 0. 1/10 or 1 over 10 squared is the same thing as 1 over 10 times 1 over 10. Multiplying straight across gives us 1 over 100. Lastly here, negative 3/5 squared would be the same thing as negative 3/5 times negative 3/5. A negative times a negative is going to be a positive 9 over 25. Now, looking at these, which like I said, you don't have to write them down, but looking at these, besides the 0, maybe, what do we notice about all of our numbers? What do they all have in common?
Now the exponent of 2.
Okay, the exponent of 2. And then what do they come out to be? Heard somebody say it, I think. They're all positive. Did somebody say that? I thought somebody said that. They are all positive. Okay. So squaring any real number gives us a positive answer. Okay. But the reason why I wanted you to get you guys thinking about this is because now we're going to ask ourselves, well, what happens when we square imaginary numbers? Okay. I want you guys to write down these 2 things here, and then we're going to write out something beside of it. So just like we saw in that last little slide, anything raised to a power of 2 means we are multiplying it by itself. So here we can see I squared, which again, I is an imaginary unit. It is an imaginary number. It is not a variable. But I squared equals I times I, which like we stated on that first introductory slide, I squared itself equals -1. Okay? Now, if we take I squared equals -1, which you can just keep writing underneath this, I have to draw a little arrow. But if we take I squared equals -1 and we solve for I by taking the square root, because we're going to hear this more in future units, So remember, square root undoes an exponent of 2. So that leaves us with I equals square root of negative 1. Okay, so I squared equals negative 1. So again, solving I squared equals negative 1 by taking the square root of both sides shows us that I equals square root of negative 1. Okay, give me a second. Would you have that down? Put your pencil down. By accepting that I exist, we can now solve things that need the square root of a negative number. Because up until this point, so like prior to today, you have been told that you can't take the square root of negative numbers because they are not a part of the real number system. But like I said, I gives us a way to actually take the square root of a negative number. So, for example, what is the square root of negative 9? Now, you don't have to write down the words, but I want you to write square root of negative 9. Negative 9 is equivalent to negative 1 times 9. So we can rewrite that radical as the square root of negative 1 times 9. Using the properties of radicals, which you should have been exposed to last year, I believe, we can break this up as the square root of negative 1 times the square root of 9, because if you've got multiple things underneath your radical, you can break them up like that into multiple radicals. Now, we just stated in that previous slide that I is equal to the square root of negative 1. So I'm going to replace the square root of negative 1 with I, and the square root of 9, hopefully we all know, is 3. Now, somebody tell me, and it can be anybody, what is I times 3? You might know.
3i.
3i. It's just like x times 3 is 3x. I times 3 is 3i. Okay. Let's keep going. What if we had, which we're just going to do these ones for fun. You just write them on your paper. What if we had the square root of negative 25? We said the square root of negative 9 is 3i. So somebody tell me what you think the square root of negative 25 would be. So again, we said the square root of negative 9 equals 3i. So looking at that pattern, somebody tell me what you think the square root of negative 25 is. 5i. Okay. Let's keep going, just a couple of things. What if we had the square root of negative 49?
Negative 7.
7i. So tell me, looking at these, where do the i's come from? Why do we put I? Because it has what underneath the radical? The negative. Now, what if we had square root of negative 5? Can we take the square root of 5? No. So we still have to put that I up front, but the 5 would stay underneath the radical. So do you see the difference between this here and these two? Because 25 and 49 are perfect squares, but since 5 is not, it has to stay underneath the radical. So in general, and I want you guys to write this down. In general, the square root of negative x equals I on the square root of x. This is something that we are going to work on in today's lesson, as well as in future lessons. But anytime you have a negative number underneath your square root, you pull the negative out and put I up front. And once you have that down, put your pencil down for a brief moment. You got another moment. Just put your pencil on your note. Okay. So let's look at raising I to a little bit higher power. Since we know that I is I, we know I squared is -1, but now what about I cubed and I to the 4th? So everything that I'm writing down, I want you to write down. So we said that an exponent is just a visual representation of how many there are. So I to the 3rd is equal to I times I times I. Now, we know for a fact that I squared equals -1. So we are going to use that fact to figure out what I to the 3rd is equal to. So I'm going to group these by 2, because again, we know I squared, which is 2 i's, equals -1. So I'm going to replace this I times I with -1. Okay, again, because we know I squared, and I want you to make a little cloud over to the side of your paper because we're going to write some key facts. So we know I squared is -1. Somebody tell me, what is -1 times I right here? What does that equal? What is -1 times I? Negative I. So I cubed is equal to -I. We are going to list that with our key facts. Okay. So I cubed equals -I. Let's do the same thing with I to the 4th. So I to the 4th represents 4 i's. So I times I times I times I. Again, we're using that key fact that I squared is -1, and we're going to group these 2 i's and these 2 i's. Again, we know I times I, which is I squared, is equivalent to -1. Close. What's -1 times -1? 1. So I to the 4th equals 1. Add that to your list of key facts. Okay. Now I want you to make 2 little notes. One I'm going to write, one I'm not going to write up here. But I want you to leave I as I. If you are working with an expression and you see simply just I, it has no exponents, you're going to leave it alone. Okay? We're going to leave it alone. Because sometimes students have the misconception of knowing that I is equal to square root of -1, and they want to try to substitute in something for it. You're not. Okay? The other little note that I want you to make out from your little cloud of facts is memorize. These 3 facts, that I squared is equal to -1, I cubed is equal to -I, and I to the 4th is equal to +1, you have to have memorized for the Unit 3 test. As of right now, it is on our calendar on our board as well as the calendar on Google Classroom. As of right now, the Unit 3 test is scheduled for the 23rd. That should not change for my first period kids or for you all. The only people it might affect is 4th period, and like I said, it just depends on that pep rally that we may or may not have. But memorize out from this because you need to know this by the time you take the test. I'll give you a quick moment if you're still getting that down. So we have created our little list of facts, okay? We are going to use these throughout the rest of the lesson, and on the homework, you will use them throughout all of your 8 problems, okay? Or 7, whichever one it was. Well, let's go ahead and keep going. So in general, I do want you to write these down. So write down these 2 things, and I will give you a moment. But in general, I to the nth power, with n being any number you can think of, is equal to I to the r power, where r is the remainder of the number n when divided by 4. Okay? So in general, I to the nth power is equal to I to the R power, where R is the remainder of the number n when divided by 4. Okay. For that first, now that is not example 1. These are just a couple little bonus examples, if you will. But it says evaluate I to the 7th. Okay. That's going to be the first one that we look at. If you haven't reset your calculator, go ahead and do so. I'll give you a second to get that down more. Actually, know what to do. Give you a second. So our goal in these next couple of examples is to practice raising I to some higher power, okay? Because we know what I squared is, we know what I cubed is, and we know what I to the 4th is, and we use those 3 facts to evaluate I to some higher power. So let's look at I to the 7th. Now, the pattern for doing this is to take that exponent and divide it by 4. Now, if you are good at long division, you are welcome to do this by hand. But I know when you get to bigger numbers, so like if I said, hey, what is I to the 352 power? That can get a little bit more, I don't want to say intense, but difficult for some of us. So I'm going to show you how to get the remainder on your calculator. Okay. So I want you to type 7 divided by 4. You are going to click math, and you are going to go over to the tab that says FRAC. That means fraction. You are going to go down to option number 4. Now, when you click option number 4 and you click enter, it's going to just spit your fraction back out. Okay, so you can see 7 over 4 is an improper fraction. If you click math, go over to frac again and choose option number 4 a second time. That's going to change it from an improper fraction to a mixed number. Okay, so 7 divided by 4 is equivalent to 1 3/4. I want you to make a note that that 3 there is our remainder. So what that means to us is that I to the 7th is equivalent to I to the 3rd. Because you can see that we had I to some number, and that's equal to, when the R is the remainder of the number, n divided by 4. So we took 7 divided by 4, got that remainder. Now, we said that I to the 3rd is equal to negative I. And that's right. Okay. Go ahead and write down this one. You don't have to write evaluate if you don't want to. But go ahead and write that one down. So this one's just a little bit more complex. But it says evaluate I to the 17th plus 2I to the 15th plus 3I to the 12th power. So again, evaluate I to the 17th plus 2I to the 15th plus 3I to the 12th power. Okay? Now, let's go ahead and work each of these separately. So we're going to start with I to the 17th because you have to do each I individually. Okay? So if we take 17 divided by 4, we're going to do this on our calculator again. So I want everybody to do this with me. So type 17 divided by 4. Click math. Go over to fraction. So FRAC. And you're going to choose option number 4. Now, you have to do that again. So we're going to do math, go over to fraction, choose option number 4, and that will tell you that 17 over 4 is equivalent to 4 1/4. That 1, again, is our remainder. So that means I to the 17th power is equivalent to I to the first power. Okay. I'm going to bring down my plus 2. Since we have a coefficient, I'm going to put us a little open close parentheses so we can put what I to the 15th power is. Okay. Again, we have to do each part separately. So I'm going to do I to the 15th now. Maybe. Nope, just kidding. This is not going to change for me. There we go. So we're going to do 15 divided by 4. Again, let's type 15 divided by 4. Click Math. Choose option number 4 from the Fraction tab. Click Math. Go over to Frac. Choose option 4 a second time. And that's going to tell us that 15 divided by 4 as a mixed fraction is 3 3/4. Again, the numerator, which I'm going to abbreviate remainder as REM this time, but the numerator is your new exponent because that's the remainder. So we're going to have I to the 3rd. Last one, we have I to the 12th. So we're going to do the same thing. We're going to do 12 divided by 4. Now, most of us are looking at that and you're like, well, 12 divided by 4 is 3. If it comes out to be a whole number, okay, if it comes out to be a whole number, that means your remainder is 0. And I want you to make that note. If you divide a exponent by 4 and it gives you a whole number, okay, that means your remainder is 0, and that's what you're going to put as the exponent on your I. Okay. Now from here, it's evaluating what each of these things are equivalent to. So for that first one, we have I to the first power. Anything raised to a power of 1 is simply itself. So we're going to have I cubed, we said, was negative I. So we're going to replace that with negative I. And then somebody tell me, if we raise anything to the 0 power, what does that equal? It's the exponent property. Close. So you guys are saying 0. What is it? 1. So anything raised to a 0 power is 1. At this point, we are going to multiply and combine any like terms that we have. Okay? So I'm going to show this in red, but we're going to do 2, maybe not, 2 times negative I and 3 times 1. We're going to bring down that first I. 2 times negative I is negative 2I. 3 times 1 is 3. From here, you are going to combine like terms. Because again, the key takeaway when it comes to working with complex numbers and working with imaginary numbers is to keep in mind that I is not a variable, but we treat it as such. So if I were to ask you, what is x minus 2x? Hopefully you would say negative 1x or negative x. So that means that I minus 2I is negative 1I or simply negative I. We're going to bring down that plus 3. Last thing we have to do is rewrite it in A plus BI form. This is something, again, we're going to develop the habit of over the next few class periods. But we're going to put the real part first, imaginary part second. So our final answer is 3 minus I. And once you have that down, put your pencil down for a moment. Once you got this down, put your pencil down. Okay, I think we're good. So I want you to write example 1. I do not want you to write the directions. But it says select all expressions that result in a non-real number when simplified. Now, I do not want you to stress right now about writing down all the answer choices. We're going to go answer choice by answer choice. So as we go to a new one, you will write it. So let's start with this first one. So go ahead and write down this first one. And I do want you to draw the little box because we're going to check them or not. So for our first answer choice, we have I times the square root of negative 16 times the square root of negative 100. You have a problem similar to this on your homework. I think actually, maybe just one. It's one or two of these. But you're just going to simplify each answer choice. And then for this question, it wants to know which ones are non-real. So we will select the ones that are non-real. Okay. So let's look at this first answer choice. We've got this I in front of this radical. So I'm going to pull that over. Now, we said earlier that the square root of negative 9 was 3i. We said the square root of negative 25 was 5i. We said the square root of negative 49 was 7i. So somebody tell me what's the square root of negative 16? What's the square root of negative 16? 4i. Okay, so we're replacing square root of negative 16 with 4i. Then we have times. And then building off of that, Elijah, what's the square root of negative 100? 10i. Because we've got that negative, so it is 10i. At this point, since we are multiplying, because that's what this operation is, you are going to multiply the coefficients. So 4 times 10 is 40. We're going to count up how many i's we have. So we have 1, 2, 3. So I cubed. And we said I cubed, Gene, is equal to what? You can look in your notes, but what is I to the third power equal to? Look in your notes. We wrote it in a little cloud. Yes, so negative I. So we're going to replace I cubed with negative I. And then 40 times negative I is just negative 40i. That's simplified. Is that real or non-real? It is non-real because, again, what makes it non-real is having the I. So we are going to check this answer choice. Okay. Once you have that down, go ahead and write down our second answer choice. So our second answer choice is negative 3i squared plus square root of 9i squared. So again, our second answer choice that we are going to simplify is negative 3i squared plus square root of 9i squared. Again, work down the line in these expressions. Go left to right. So looking at the first part of this expression, we have an I squared, which we know to be negative 1. That's one of our key facts. So I'm going to replace that I squared with negative 1. Okay. Then we have plus. Now, I'm going to make this little note over here, but you guys just put this somewhere on your paper. The square root of 9i, or 9x squared, I should say, is 3x. Okay? Because the square root of 9 is 3. Square root of x squared is x. Building off of that little fact, somebody tell me what you think the square root of 9i squared is. 3i. Good. Okay. So it's same concept. Again, I is not a variable, but when you're working with it, it's very similar to it. Okay. Again, at this point, we're going to multiply. So negative 3 times negative 1 is positive 3. We've got our plus 3i. All we're left with is a constant and an I. So that's simplified. Is that expression real or non-real? Non-real, because again, the key thing is looking for the I. Once you have that one down, go ahead and write down the third answer choice. So for our third answer choice, we have negative I cubed times I cubed. Again, for our third answer choice, we have negative I cubed times I cubed. Now, again, when you are working through this, if you see an I cubed, we need to replace it with negative I, like Jean and Louise said, okay? So we're going to pull this negative over. We're going to replace I cubed with negative I times I cubed, which is again is another negative I. Okay. Distribute a negative times a negative I is going to change that to a positive I. So I have I times negative I. We know positive times a negative is a negative. And somebody tell me, what is I times I? I to the, how many are there? 1 and 2. So I to the second. What is I to the second equal? Negative 1. So we're going to replace I squared with negative 1. So we have negative 1. Because you got to keep this negative that's in our problem. And I squared, like Brittany said, is negative 1. And this is going to equal positive 1. Real or non-real? It is real. So are we going to check it? No. If you would like to try these bottom two answer choices, I'm okay with you trying them. I'm going to go over them for time's sake and for video sake. But go ahead and write down our fourth answer choice if you don't already have it written. So for our fourth answer choice, we have 4i minus the square root of 25i squared. Again, that fourth answer choice is 4i minus the square root of 25i squared. Again, simplify these from left to right. For this part, all we have is that I. And remember, if it's I, you're going to leave it as I. So we're going to have 4i minus, and then Carmela, looking at what we did with the square root of 9i squared and what we got, tell me what's the square root of 25i squared? Close. Is it going to be squared? No, it's just going to be 5i. So I have 4i minus 5i. Now, thinking back to what we just did in that last problem where we ended up with 3 minus I think it was what it was. We need to combine like terms. So what is 4i minus 5i? What's that going to equal? Negative I. Or you can put negative 1i, just know those are the same thing, but we get negative I. Good. Real or non-real? Non-real. Last answer choice. And again, if you feel like you can do it, be my guest. But for this last answer choice, we have negative 9 plus I on the square root of 36i squared. Again, for that last answer choice, we have negative 9 plus I on the square root of 36i squared. Remember, left to right. We can't do anything with the negative 9, so we're just going to bring it over. Plus I, because we've got this I in front of this radical now, we're going to put in parentheses what the square root of 36i squared is. So, Justin, what is the square root of 36i squared?
6i.
Perfect. 6i. So I'm going to put that in parentheses here. Okay. We're going to distribute the I into the 6i. I heard somebody say 6i squared over here. Yeah, that's right. So we have negative 9 plus 6i squared. We've got an I squared, so we've got to replace it with negative 1. So I'm going to have negative 9 plus 6 times negative 1. 6 times -1 is -6, if I can write an equal sign right. And -9 minus 6 is -15. That is simplified, real or non-real. It is real, so we are not going to check it. I know that example was a lot. Just know in a different life, you have guided notes for every single lesson, but it is what it is. Once you have this down, put your pencil down. Give you guys another moment. Now, we'll say, besides one more example, most of the examples are not that intense. But you guys did good with that, so that's okay. So, I want you to go, I forgot about this slide. So, real quick, as you guys saw, really in that last example, complex numbers and imaginary numbers are, again, like I keep saying, very similar to variables. So, when adding or subtracting complex numbers, you simply combine like terms like you would with variables. And when multiplying complex numbers, we distribute and then simplify as necessary. Okay, so let's practice that a little bit more. I want you to write down example 2, and then I'm going to highlight what I want you to write from this example. So it says, in the equation 12i cubed plus square root of -25 equals a plus bi, what is the value of b? So again, 12i cubed plus the square root of -25 equals a plus bi. Now again, when I work with things like this, just like we did in the last example, I work left to right. So going left to right down that equation, the first thing that we come across is the I cubed, okay? We have stated a couple of times now that I cubed is equivalent to -I. So I'm going to start by replacing that. Okay. Gabriella, what is the square root of -25? 5. 5i. We're going to just bring down the equals a plus bi. If you're asking yourself, well, what am I supposed to do with that? Nothing. That just tells you to make sure it's in that form. We're going to distribute the 12 to the -I. Louise, what is 12 times -I? What's -12i? Yeah, see, you do know. -12i plus 5i equals a plus bi. Again, don't get hung up on this right side of the equation. It just tells you to put it in the correct form. Now, the next thing that we can do is combine like terms. So somebody, and it can be anybody, tell me what is -12i plus 5i? -7i. Again, if you are not good at combining like terms, pick up your calculator, and it's okay to do this. Do -12 plus 5, you will get -7, and then you're going to keep the I. Now, looking at a plus bi form, what are we missing? The a. What did we put as a placeholder in that table when we were missing the a value? 0. So I'm going to rewrite this as 0 minus 7i equals a plus bi. Now, looking at the wording of this equation, or this problem, I should say, what does it actually want from us? The value of b. So, Carmela, what is the value of b in this problem? Perfect, -7. So I do want you to make a note, just because I know you don't have the problem in your, like on your paper, but I want you to put a equals 0 and b equals -7, like Carmela said, but since this was wanting the value of b, it would actually be the -7. Once you have that down, put your pencil down. For time's sake, and I did the same thing with first period. I'm going to skip the next example. So example 3, just know that I am going to upload the completed notes, and they will be, or example 3 will be done. But we're going to skip it for now. If we have time, we'll come back to it. But I want you guys to go ahead and write down example 4. And again, I want you to write this expression. So example 4 says, write the complex number -3 minus I minus -7 plus 8I in A plus BI form. So again, this problem says, write the complex number -3 minus I minus 7 or minus -7 plus 8I in A plus BI form. Now, we're going to talk about this over the next few examples, but I want to make a note here that you cannot double distribute here because of this minus sign here. Because some of you guys may have been thinking that, because I know oftentimes with students, you see those two parentheses and you automatically think double distribution. But if they've got something in between them, so something's splitting them up, you cannot do that. Okay? So, what I like to ask myself, and you're going to hear me say this a couple of times over the next few examples, do we have anything that needs to be multiplied into this first one? No, because there's nothing in front of it. So we are going to drop the parentheses. Ask ourselves the same thing. Does this have something that needs to be distributed into it, or can we drop them? What's in front of it? What's technically a negative here? A negative what? 1. Do we have to distribute a -1? Yeah. So I want you to make a note. If you've got a negative sign there, you have to distribute that. That is a common mistake that students make. Okay. So -1 times -7 is +7. -1 times +8i is -8i. And then from here, since we're just working with an expression and not an actual equation, we're just going to combine like terms, be done with it. So again, take care of the real part first. So the real numbers we have are -3 and +7. Again, if you're not good with doing things in your head, don't sweat it. Hop in the calculator. But -3 plus 7 is +4. Our imaginary parts are the -I and the -8i. If I can do this in a different color, that would be great. We technically have a -1 and a -8, so it's going to be -9i. Once you have it down, put your pencil. And if you're asking yourself, is that it? Yeah. Hang on just one second. Okay. Let's look at example 5. Same thing. I want you to write example 5 and then the expression itself. I'm not going to highlight it because I think you guys are catching on to what you're writing down. But example 5 says, write the expression -4i times 2i minus 3 times 5 minus 2i in A plus BI form. Again, this one states, write the expression -4i times 2i minus 3 times 5 minus 2i in A plus BI form. Again, the way that I do these is I start by distributing anything that has to be distributed. So we're going to multiply the -4i times the 2i, and then we're going to multiply the -3 here by each of our terms in our parentheses. Now, I want you to pay close attention here. -4 times 2 is -8. What is I times I? I squared. Please do not forget that. Okay? That's another common mistake that I see kids make. Distribute the -3. -3 times 5 is -15. -3 times -2i is +6i. Because again, -3 times -2 is +6. Since this is the only one with I, you just bring it down. Hopefully you're catching on and you're thinking, okay, we need to replace the I squared with -1. If you're thinking that, you are correct. So I squared is equivalent to -1, so we substituted it. -8 times -1 is +8 minus 15 plus 6i. And then the last thing that we do is combine like terms. And the only like terms that we have is that 8 minus 15. And 8 minus 15 is -7. So we have -7 plus 6i. Once you have that down, put your pencil in. Now, I'm going to say that the next example is a little bit more writing, just because there's one on your homework just like it. So I want to make sure that you have it completely written down, and we're doing extremely well on time. So we've got the time. I'll give you just another moment. Okay. So for example 6, obviously you do not have to write down the actual directions, but all of this I do want you to write down. And I'm going to give you a moment to do so. So example 6 is similar to one of the last couple problems on your homework. Okay. Now, even though at first glance you're like, oh my gosh, this is going to be so much work, it really is not. However, one of my goals as your teacher is to make sure you are prepared for the EOC as much as possible. And these are common benchmark questions. They're common EOC questions. So again, even though there is, Algebra 2 skills in here of being able to work with these imaginary numbers and everything, it's also being able to understand how to work these problems and what it's asking from you. Okay? So I try to make sure we're exposed to it. But example 6 reads, identify whether each expression is equivalent to a real number or a non-real number. So you can see it has real and non-real, and it has a little circle for each of those. And we've got 3 different expressions that we are going to simplify. Okay. Now, again, one of the things that this problem is assessing is, can you work with imaginary numbers? But it's also, do you understand what the difference between this, and this is? Okay. So let's make sure that we're in a good place. I'm going to erase all these lines, maybe. Here we go. So I'm going to label these as 1, 2, and 3. I did that with first period, and I'm going to do it with you guys in fourth period as well, because I feel like that's the easiest way to keep up with what work went with what expression. So for the first one, I'm going to just have to do it over here. We have 3 plus 3i, 3 minus 3i. Now, the thing that's different here compared to what we've seen in the last few examples is that we've got 2 parentheses side by side, and there's nothing splitting it up. So if you've got 2 parentheses side by side like that, you do have to double distribute here. If you are good at double distribution, you go ahead and try it. But I know that with my kids, it's usually about 50% of them that are really good with it, and then about another 50% that struggle or mess up little things. So let's review that here. I'm going to start with the 3, and I'm going to multiply that by each of the terms in my second parentheses. Okay? So 3 times 3 is 9. 3 times negative 3i is negative 9i. So I've taken care of that. Now, we're going to do the same thing with the 3i. So we're going to take 3i and we're going to distribute it or multiply it by each term in the second parentheses. 3i times 3 is 9i. 3i times negative 3i is negative 9i squared. Now, make sure that you understand where the negative 9i squared came from. 3 times negative 3 is negative 9. I times I is I squared. At this point, I'm going to do 2 different things. I'm going to combine like terms and also change that I squared that we have to negative 1. Now, what do we notice about our negative 9i and our positive 9i? What happens with those? They cancel because they've got same coefficient, just opposite signs. So I'm not going to mark mine out just so that way you guys can see this. But these cancel, leaving us with the 9 and then the negative 9 times negative 1. Okay, because I combine like terms, they canceled. Replace I squared with negative 1. Negative 9 times negative 1 gives us positive 9, and 9 plus 9 is 18. So this first expression is equal to 18. Real or non-real? Real. Real. You can check this. I'm just going to scribble it in. Okay. And give a quick second. I'm going to scroll down a bit. Okay. Let's look at expression number 2. So expression number 2 is 3 plus 3i plus 3 minus 3i. Now again, we do not have to double distribute because there's something splitting those parentheses up. So then it comes to asking ourselves the questions that we asked ourselves in example 3, I believe. And it's, is there anything to distribute? Is the parentheses necessary? We have nothing to distribute here. So we're going to drop them. So 3 plus 3i. Now, we talked about earlier how we have to distribute a negative. Does it make a difference to distribute a positive? No, so we're going to drop them. Combine like terms. We have 3 plus 3, which is 6. 3i minus 3i cancels. So this is equivalent to 6. That again is real. Now I'm going to do the work for number 3 right here because I have the room. But for our final expression in this example, we have 3 plus 3i minus 3 minus 3i. Again, right here, we don't have anything in front of us that we need to distribute, so we're going to drop the parentheses. We stated earlier, and then again just now, that a negative, we do have to distribute. So a negative times a positive 3 is going to be a negative 3. Negative times a negative 3i changes it to a positive 3i. This time, our constants cancel. Because 3 and negative 3 gives us 0. And what is 3i plus 3i equal to? What's 3i plus 3i equal to? 6i. Oh. Real or non-real? Non-real. Once you have that down, put your pencil down. We are going to do one final problem, and then we will call it a day. I'm not going to make us go back to the example 3 that we skipped. Like I said, I will just do that and upload that. So maybe a moment. Once you're ready to move on to the final example, put your pencil down. It's okay. You're not on your phone, so it's fine. I'm recording, so that's lovely. It's fine. It don't matter. Because I'm not recording for the periods again. Okay. Good? Yes. Go ahead and look at our final example. Now, I felt like example 6 was a really good place to just touch base one more time about, do we know how to work with imaginary numbers? Do we know how to differentiate between real versus non-real? However, like I said, one of the skills that I see my kids struggle with every year is double distribution. So that's why I made this our last example. So if you felt good on the last one, you are more than welcome to try this problem all on your own. And I am okay with that. But again, if you struggle, and you know you struggle, follow along with me. Okay? Example 7 says, write the expression negative 10 minus 4i times 2 minus 3i in a plus bi form. Now, like I've already stated, we are going to double distribute here. But again, the reason that we know this, or the reason that you should know this, is because there is nothing splitting these parentheses up. Okay? I'm going to do this in different colors just like I did over here in this expression, just because I feel like that helps you visual people. But we're going to start with the negative 10, and we're going to multiply it by each term in that second parentheses. Okay? Then we're going, let's do that one first, and then we'll do the negative 4i. Negative 10 times 2 is negative 20. Okay? Stephanie, what is negative 10 times negative 3i? Okay, you're close. It is going to be 30, but a negative, yeah, okay. Now, is it going to be I or I squared? Perfect. Thank you. I was about to ask you how you knew. You went ahead and answered that. So she said it's going to be a positive 30i because this has an I, but the negative 10 does not. So just be careful about that because that's where it gets, kids. Now, let's do the same thing with the negative 4. So we're going to do negative 4i times each of these. Negative 4i times 2 is going to be negative 8i. Negative 4i times negative 3i is going to be a positive 12, but what's going to go with it? I squared. Again, the difference is both of these have an I, so it's going to be I squared. Now from here, I'm going to do two different things. I'm going to go ahead and combine my 30i and my negative 8i, and then I'm also going to replace I squared with negative 1. So I'm going to do two things at once. So I'm going to bring down the negative 20. Positive 30i, negative 8i gives us a positive 22i. I'm going to replace I squared with negative 1. Now, I want to just say this one last time because this is our last example. Make sure here that you understand that when you replace I with negative 1, that you are multiplying that by the number that's with it. A common misconception that I don't see from a ton of my kids, because I try really hard to stress it, but sometimes I've seen students where they say, okay, 12 minus 1 is 11, and they write 11. You are multiplying it, okay? So we're going to have negative 20 plus 22i minus 12, because positive 12 times negative 1 is negative 12. And then from here, combine your constants. So negative 20 minus 12, either in your head or on your calculator, gives us negative 32 plus 22i. For fun, just review this one final time. What is A? What is A? Negative 32. What's B? 22. Perfect. Once you have that down, because like I said, I didn't make first period go back and do that final example, so I'm not going to be unfair to you all and do that. But just know that it will be uploaded with hopefully this video. So once you get this down, put your calculator up and get your phone. Okay.